Hello friends, this is once again Vinod Sharma, your friend with you. Again, the next video of the Pulley System series. This time we are going to discuss about the tension in string. What are the reasons so that the tension is created in string and what are the uses of this tension in the pulley system. So first of all, let us see what the tension is. Actually, tension is a force. When a one-dimensional object, maybe a string, maybe rope, maybe chain, maybe rubber belt or any other thing, when it is pulled from both the ends, when it is pulled from both the ends, suppose it is being pulled from this side as well as from this side, then this pulling force, that it is P1, this is P2, this pulling force creates a tension force T in this rope or string. This is the tension. So tension itself is a force which is created in a one-dimensional object, rope, for example rope, string, chain or pulley rubber or other things also. It is a force which is created in one-dimensional object when it is being pulled from both the ends of the rope. This is tension. Suppose, let us see an example. Let it is a weight of n kilogram. It is attached with a string. This is a string. And suppose this is kept on the first floor. This is kept on the first floor of the building. This is the ground floor. Let this is 5 meters away, 5 meters above. Let first floor is 5 meters above the ground floor. This mass is attracted towards the earth and having its weight mg. This mass is having a weight mg. If we release this mass and let it fall free, what will happen? This will come down and will reach to earth. So during its free fall or when it touches the earth, will there be any tension in this string? Certainly not. There will not be any tension in the string because its other end, the other end of the string is free, it is not being pulled. It is being pulled from this end which is attached with the mass, but not pulled by the other end, other free end. Therefore, there would be no tension at all in this string. Or we can say the string would not be stretched at all. Now, suppose this mass is hanged. Let it is hanged in air, M, with a string, and this string is held by a man who is standing on the first floor. It is held by a man. So this mass is attracted towards the earth with its weight force which is equal to mg, and this string is also attracted by is being pulled by this man. So this string is stretched from both ends. This end is pulled downward, this end is pulled upward by the man. So due to these two pulling forces, this string will experience a force, a tension force. This is known as tension force. So tension is a force when a string is attracted, is pulled from both the ends. Then a tension is created. Now, if this force by which the string is being pulled by this man is equal to the force which is at this point, which is equal to mg force. If these two forces are equal, exactly equal, then it will suspend in air in equilibrium. Then this mass will suspend in air in equilibrium. It means neither it will go up and nor it will go down. It will be in equilibrium. If the pulling force of this man is larger, if the pulling force of this man is larger than its weight, then what will happen? It will experience an upward motion. This mass will experience an upward motion, and we can say, since motion is there, certainly it will have some acceleration. So this mass will be accelerated upward. If this pulling force is greater than the mg force, then this mass will move upside, and it will experience an acceleration in the upward direction. On the contrary, if this force is lesser, if the man pulling this stretched string is lesser than its weight, then what will happen? The weight will move down with some acceleration A. So if both the pulling forces are equal, the mass will be suspended in equilibrium. If above force is larger, then it will experience an acceleration upward. If lower force is larger, then it will experience an acceleration in the downward situation. I hope it is clear. Now let us take an example once again. Let it is a beam, permanent beam. With this beam, a rope is tied, and at one end of this rope is mass m is attached. This mass is having the weight mg, which is the downward force for mg Newton. Then this string is pulled downward with the mg force, downward, and of course it is being pulled upward also by the beam. It is being pulled upward also by the beam. So it has pulling force on both its ends. This has pulling force on both the ends of the string, so there would be a tension in the string. There would be a tension force in the string. And always remember, tension will be away from the body. The direction of tension will be away from the body. This is the body which is being suspended. So the tension force in the string would be this way. Always remember, the tension force in the string would be always away from the body. This is the tension in this one. So let us take another example. Yes, one thing more. If this is being suspended in air in equilibrium, it means T would be equal to mg. If this is suspended in equilibrium, then T would be equal to mg. So tension force would be equal to mg force, or we can say T minus mg equal to 0. So this is the concept that we shall use again. Let us take another example of tension. Suppose this is a beam. This is a beam, fixed beam. This is a fixed beam. At one of its end, a string is tied. At other end, again a string is tied. And let this is the knot. At this knot, and the string is tied, and at one end of this string is the mass m. So this is the mass m of the block, which is being attracted downward due to earth and having its weight mg. Mass m, weight mg. Let this angle is 60 degree. This thread is making an angle of 60 degree, and let this is making an angle of 30 degree, and certainly this would be an angle of 90 degree. Now, since this thread is tied at one end, and again it is being attracted, it is being pulled downward, so this thread will experience a tension force. Similarly, this thread that is tied at one end and also being pulled at the other end, so it will also experience a tension force. Similarly, this string that is tied at this end with the knot, and at the other end it is being pulled by the mg force. This will also have a tension force. So these are the three tension forces. Let this tension is equal to T, this tension force equal to T1, and this tension force equal to T2. Now we have to find what would be the tension T1, what would be tension T2, and what would be tension T. So we shall use our vector addition law that we have discussed in our vector series. So this is force is a vector quantity, tension, this is tension. Let us resolve this force. This is horizontal, this is vertical, and this angle would be equal to 60 degree. Similarly, resolve this force, this tension force. This angle would be 30 degree, and another would be part this one here. So this would be, there would be two forces, one perpendicular portion of this vector and other perpendicular vector of this vector. Its horizontal vector is in this direction and its horizontal vector is in this direction, horizontal force. With this tension, since it is not making an angle, it is directly upward, so its total upward component is T and horizontal component is 0. I think it is clear. Now let us resolve these forces. This is T1, this would be T1 cos 60. This is T1 cos 60. This is T2 cos 60. Sorry, cos 30. T2 cos 30. This would be the addition of both the forces. This would be addition of both the forces. It means it is T1 sin 60 plus T2 sin 30. And this is T, which is the upward one. Since force is directional quantity, let us make force in the rightward direction is positive, force in leftward direction is negative, force in upward direction is positive, and force in downward direction is negative. We are taking this convention: rightward force positive, leftward force negative, upward force positive, downward force negative. Now T1 cos theta, this is the origin point of origin. This is towards right, it would be positive. This would be negative. This would be positive. This would be negative. I think it is clear. Now this knot, since the system is in equilibrium, then horizontal portion will be cancelled out. Very clear. So we can say T1 cos 60 would be equal to T2 cos 30, or we can say T1 upon 2 equal to T2 into root 3 by 2, because cos 30 is root 3 by 2. Then T1 equal to T2 into root 3 by 2 into 2 cancelled out. We can say T1 equal to root 3 times of T2. This is a relation that we calculated, that T1 equal to root 3 times of T2. Now let us find out the other values also. Now let us consider the vertical components. These two vertical components are positive, this vertical component is negative, and they are counterbalanced. Since it is in equilibrium, not in equilibrium, it means the positive force is balanced by the negative force. So T1 sin 60, T1 sin 60 plus T2 sin 30 is equal to mg force. Here T1 sin 60 is root 3 by 2, root 3 by 2 plus T2 sin 30 is 1 by 2 equal to mg. We have T1 root 3 by 2 plus T2 by 2 equal to mg. And we just calculated T1 is equal to root 3 times of T2. So put this value of T1 here, then root 3 times T2 into root 3 by 2 plus T2 by 2 equal to mg. This is 3 T2 by 2 plus T2 by 2 equal to mg, or we can say this is 4 T2 by 2 equal to mg and 2 T2 equal to mg and T2 equal to mg upon 2. So we calculated the T2 tension, this tension. T2 tension is equal to half of the mg. Very clear? Then T1 would be root 3 times T2 equal to root 3 by 2 mg. So this is T1 tension. We got T1 root 3 by 2 mg. We got T2 mg by 2. Now let us find out the T tension. You see, T is equal to mg. T is equal to mg. So T equal to mg. So we came to conclusion T equal to mg, T1 equal to root 3 by 2 mg and T2 equal to 1 by 2 mg. These all the three tensions are calculated in this string system. I think it is clear. There should not be any confusion in this one. Is there any? So by seeing this example, we calculated how the tension works. In other video, I shall describe more examples, so that each and every detail of this concept will be clear to both of you, or all of you. So if you like this video, you please subscribe my channel, so that whenever I upload a video, you will be intimated at your own. Thank you very much.